So in this video, we're going to look at solving equations. So the first thing we're going to do is differentiate between equations and inequations. And the difference is the sign in the middle of the equation or the inequation. So equations have an equals sign in the middle. So we're saying that the left-hand side equals the right-hand side. And inequations have an inequality sign. So we're saying that the left-hand side is less than the right-hand side, or it's less than or equal to the right-hand side, or perhaps the left-hand side is greater than or equal to the right-hand side, or greater than the right-hand side. So in our first example, we're going to be solving an equation which is similar to changing the subject of a formula. And what we're going to do is we're going to gather all the variables or the letters on the left-hand side, and we're going to collect all the numbers or the constant terms on the right-hand side, and then we're going to isolate the variable, so we're going to find the value of one variable. So, example 1, we're going to solve the following equation, 2x plus 3 equals 11. So, what we're trying to do is we're trying to isolate that x term. So, first thing we're going to do is we're going to collect all of our constant terms or our numbers onto the right-hand side. So we're going to do the inverse process of add 3, and that is take away 3. So that means that we end up with 2x on the left-hand side, and 11 take away 3 gives us 8 on the right-hand side. Now we're still trying to isolate that x term. So what we're going to do next is we're going to do the inverse of multiply by 2. So the inverse of multiply by 2 is divide by 2. And so we're going to divide both sides by 2. And that means that our final answer is going to be x equals 4. And that's the solution to 2x plus 3 equals 11. And we can check by substitution. 2 times 4 is 8. 8 plus 3 is 11. So that means that when x equals 4, our equation is true. Now in our second example, we're asked to solve the following equation, 4x equals x plus 9. Now this time we have variables on both sides of our equation. So the first thing we're going to do is we're going to collect our variables onto the left-hand side. So we've got a positive x on the right-hand side, and so we're going to have to take away x from the right-hand side, and if we take away x from the right-hand side, then we have to take away x from the left-hand side. And that gives us 3x equals 9. Now that the variables are all on the left-hand side, we want to isolate that x. 3 multiplied by x is what we've got, so we need to do the inverse process. So we need to divide both sides by 3 to isolate the x. And so our solution for this equation is going to be x equals 9 divided by 3, which is 3. And then we can check that this makes sense because we can do 4 times 3 is 12, and we can do 9 plus 3 is 12, and so both sides of our equation are equal, so that means that our solution is true. The next example, we've got x equals 12, take away x. So the same thing applies. We need to gather all of our variables onto the left-hand side. This time we've got a take away x, so we need to do the inverse process. So we need to add x to the right-hand side. And that means we need to add x to the left-hand side. So we're going to end up with 2x equals 12. Now we're trying to isolate that x value, so we're going to divide both sides by 2. Because divide by 2 is the inverse process of times 2. And that gives a solution of x equals 12 divided by 2 is 6. And then we can check by mentally substituting it into our equation. We've got 6 on the left-hand side, and we've got 12 take away 6, which is 6 on the right-hand side. So x equals 6 is a valid solution. Our final example, you can see we've got variables on both sides and constant terms on both sides. So we're asked to solve 3x plus 1 equals x plus 7. So the first thing we want to do is we want to gather or collect our constant terms on the right-hand side. So we want to do the inverse of add 1. So we're going to take away 1 from both sides. And that gives us 3x equals x plus 6. Now, we've got variables on both sides, so we need to collect our variables onto the left-hand side. So we're going to do the inverse of add x, which is take away x. So we're going to take away x from both sides, and that gives us 2x equals 6. Now, remember, we're trying to isolate that x term, so we need to do the inverse of multiply by 2, which is divide by 2. And so that gives us a solution of x equals 3. And then we're going to mentally substitute it back in to check. And 3 times 3 is 9 plus 1 is 10 on the left-hand side. And 3 plus 7 is 10 on the right-hand side. And so x equals 3 is a valid solution.